Welcome to question 1 of the 2011 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. For part A we're asked to differentiate the square root of 4 subtract x with respect to x. So if we inspect this function we can see that there's a function inside a function, so we're going to need to use the chain rule for differentiation. So to apply the chain rule, we can say that y is equal to the outer function, which is the square root of u, and that can be written as u to the power of a half, where u is the function for subtract x. Next we calculate dy du. So dy du is going to be power at the front is a half u, and then 1 off the power will leave an exponent of negative a half. And du dx, and this one you've just got to be a little bit careful with, is negative 1. So from our formula sheet we can see that dy dx is equal to dy du times du dx. So therefore dy dx, the derivative, is going to equal dy du is a half u, and u is 4 subtract x, and then we have to the power of negative a half, times du dx, which is negative 1. And now that is an acceptable answer for part A of this question. It is the derivative with respect to x. However, it could also have been written as the half times negative 1 gives negative 1 divided by 2, and then the u to the power of negative a half could be written as u, which is 4 take x, in the denominator under a square root sign. So that is another equivalent answer to this question. So either of those would have been accepted. So from the examiner's report we can see that 60% of students gained full marks for this question, and that it was a differentiation question involving the use of the chain rule. Some students differentiated correctly, but transcribed their final answer incorrectly, often omitting the negative sign. Some had difficulty with the index, showing it as negative 3 over 2 rather than negative a half. For part B of this question we have the function g of x, which is x squared times sine of 2x, and we're asked to find the derivative g dashed when x is pi on 6. So inspecting this function we can see it's two functions multiplied together, so we're going to use the product rule. And now to apply the product rule we're going to say that u is equal to the function x squared and v is equal to the function sine of 2x, and then du dx is going to equal 2x, and dv dx is going to equal 2 cos of 2x. So from the formula sheet we can see that the derivative d dx of a function u multiplied by v is equal to u times dv dx plus v times du dx. So therefore g dashed of x, just the derivative at this stage, is equal to u, which is x squared, times dv dx, which is 2 cos of 2x, and then we add on to that the function v, which is sine of 2x, multiplied by du dx, which is 2x. Now we need to substitute x is pi on 6 into the derivative, so that is going to equal pi on 6 squared, so we're going to have pi on 6 squared, and then the 2 I'm just going to write at the front, and then we're going to have cos of 2 lots of pi on 6 is pi on 3. Then we're going to add on to that, the 2x will be 2 lots of pi on 6, and then we're still going to have sine of 2 lots of pi on 6 is pi on 3. And now remembering our exact values, cos of pi on 3 is equal to 1/2, and sine of pi on 3 is root 3 on 2. So therefore the derivative g dashed when x is pi on 6 is equal to 2 times, and this is going to be pi squared on 36 times a half, and then the second term will be 2 times pi on 6 times root 3 on 2. And we can see this 2 can cancel with the 2 here, and that this 2 can cancel with this 2, so that g dashed of pi on 6, which is what this question asks for, is simply equal to pi squared on 36, and then the second term will be plus pi root 3 on 6. So that is the answer to part B of this question. From the examiner's report, we can see that 44% of students got this correct, with 42% of students making some progress on the question. The examiner goes on to say that the product rule was generally well used by students, however, determination of exact values was poor. Many students with the correct derivative did not get the second mark because they left the answers containing sine of pi on 3 and cos of pi on 3, rather than finding the exact values, which were root 3 on 2 and 1/2 respectively.